one. This is the chi-square one that we talked about the other day. Make sure you get a copy of the table, because in your calculator, it depends what type of calculator you are going to use, TI 84 or 83. They don't have directly the program that give you the chi-square table that we get over here. Okay, you had to go to the program and you set it up yourself. So I tried, I used to have it, but I don't have it in my calculator. So I check it, but the table is much easier. So be aware of that one, because this chi-square right to the left can be easily found by the table that I gave you. But it's okay if the program is already on your graphing calculator, you can use it. But I recommend that table that I gave you the other day, and I already posted this one. Okay, so this is the idea. We talk about it, this is going to be the confidence interval for the variance, sigma squared, and this is the confidence interval for the standard deviation. You have two quantities to determine. This is the chi-square to the right, to the left, and we talk about it that you have to use the table that I posted to be able to find it. Okay, otherwise, this is the chi-square table that I've already posted. Just make a copy and make sure it's available. There are going to be two types of problems. This is straightforward. Three numbers would be given to you: sample size, confidence level, and the standard deviation. And you just find the chi-square to the right, to the left, and you're done. But most of the time in action, when you want to do it, the actual numbers and the information would be given. So it means information that comes from the data set. So you have to find the standard deviation yourself. And you got quite a lot of this type in your book. So let's give you one example. Just make sure you understand what you do when the case arises. So this is information regarding the home ownership in 8 randomly selected states in America, and the question of a confidence interval. Okay, so let's get the example. I think I didn't give you this example the other day. Okay, so that's the problem. The percentage rates. Okay, rates of home ownership. Okay, home ownership for 8 randomly selected states. 8 randomly selected. Okay, selected states are given by, so we have the percentage in those 8. We have a 66%, 75.8. The other number is 70.9. Then we have 73.9. Then 63.4. 68.5. 73.3. and the 65.9. So these are the information. What would you like to do? We'd like to find the confidence interval for the standard deviation for the population of all these home ownership in the entire United States of America. Okay, so estimate. We want to estimate the population variance, the population variance, and the standard deviation, and the standard. Okay, a standard deviation for the percentage rate, or the percentage. That is going to be the percentage rate of home ownership. ship. But we want to do it with 99% confidence. Okay, that's a question. Okay, for this problem, you read the problem carefully, you realize this is confidence interval about the, okay, about the standard deviation. So you need to have a sample information. Okay, so the solution is going to be, so we read the problem and to find out what is this one. Is it confidence interval for the proportion, for the mean, or the standard deviation? So this is going to be for the standard deviation. So you need sample information. You see you need a sample data. The sample data would be include the sample size. The sample size is already given to 8 state. Okay, so you need a sample, a standard deviation. So you need the S. You need the S, and if you do have the S, then your confidence level is going to be 99%. Okay, which is going to be 0.99, and you'll be able to get the interval right away. Okay, so the difference is the S that you have to find it. You can find it with your calculator quickly, or if you don't want to use calculator, the previous method, but we suggest a calculator for this one. It quickly can be done, okay, to get the S. If you don't want to use calculator, it takes a bit more time, but it can be done again. Okay, so if you want to do it, you remember this is the way you are going to do it. You have to list the members, x and x squared. Then you have to add, okay, just give you the numbers in case, but in case you don't have the calculator, but even the ordinary calculators give you the standard deviation. Okay, so you square these numbers, and then you are going to find the sigma x. If you add them together, the sigma x would be, this is going to be 557.7, and then you add the squares, and if you add the square, that gives you sigma x squared, and the sigma x squared of 3901717. Okay, then you can go with the formula if you like. The s squared is equal to the sigma of x squared minus sigma x all squared divided by n, and the n minus 1. Okay, if you substitute, get these numbers, your s squared would be 19.79, and you can take the square root. The square root of the 19.79 would be 4.4. So either way, you have to find this one first, 4.4. Okay, this is happen in another problem too when we get to the last concept that we have. 60 is one of the numbers. I'm sorry, that's a 66. 66 is the first number that we have here. 66. I just show you that you square it to get these numbers, but otherwise the calculator will give you the result right away. Okay, so that's the extra job that we have. Most of the problem in your book are of this nature, and you have to find the standard deviation. Okay, any questions? So now we are ready. It's a confidence interval for the standard deviation, so we have to find the chi-square to the right and the chi-square to the left. Okay, so the sample size is 8. You have to find the degree of freedoms. Okay, so I'm going to find the confidence, the chi-square to the right to the left. So this is how we're going to start. So n is equal to the 8. So we have to find the degree of freedom. Degree of freedom is going to be 8 minus 1, which is equal to the 7. Okay, and you know that this is going to be degree of freedom of 7. You go to the table, and we check over here. The first one, we check for we have a 99%. Oh, I'm sorry. It's early. I have to set up the curve first. Okay. So what we're going to do, we are going to set up the curve. It's a chi-square one. So that is going to be the curve. So we're going to pick the 99%. You have to find the cut point to the right, to the left. Okay, this is going to be 99%. 99% is the tricky case because the leftover is going to be 1%. So you have to divide it by 2. That's going to be 0.5%. Okay, so this portion over here is going to be okay, it's going to be 0.5%. You get a 0.5% here, and you get a 0.5%, and that's going to be 0.5% over here. Okay, so the leftover of the 100 is 1%. You divide it by 2, that gives you 0.5. 0.5%. You move the decimals twice to the left, so that gives you 1, 2, 3. So that's going to be the number. So this cut point, if you like, for the chi-square. So for the chi-square to the right, we have to find the chi-square of 0.005. And this point over here is the area to the right. So that's already 99%, and the 5 would be 99.5%. And you change it, so this is going to be the chi-square of, what is that? It's going to be 0.995. So this would be the chi-square to the right and to the left. You got to be careful because on the table you do have the 99 and the 99.5% to get these numbers. I moved the decimal to change it into, it was percent. I changed it to the decimals. You see, this is 0.5%, 0.5%, not 0.5. 0.5%, so 0.5% is the same as 0.005. It's like dividing by 100. So you're moving a decimal point twice to the left. And this is going to be the same thing. If you have a 99%, it's going to be 99.5%. So we change it to that, okay? So now we already go to the table and get these two numbers. So the degree of freedom is 7. Okay, so this is going to be the 7. D of f equal to the 7. And then you move to the table to get to these two alpha. Okay, that give you the chi-square to the right and to the left. And this is the table. You see, it's the table that we have. So these numbers are going to be the alpha that we are going to be interested in. The first time we are interested in 0.995. Okay, then we move on to get the 0.005, which is the last number here. Okay, but the degree of freedom of what? Degree of freedom of 7. So this is a situation that we are going to have. Okay, that is 7. Okay, this is it. And this is degree of freedom of 7. We compare with the top and 0.995. So the first number is going to be this one, 989. Okay, so this first one is going to be 0.989. And then we get to the 0.005, which is the last one. Okay, the last number over here is going to be 20.278. This is the way you are easily we can find it. Okay, any question? So especially for 99%, be careful. There is going to be the case that you have 99, this is a 0.99, but this is 0.995. So the chi-square to the left would be 0.989, and the chi-square to the right, which is always the bigger number, is going to be 20.27. Okay, so I'm going to put it over here. So the first number that I have is going to be 0.989, and my second number is going to be 20.278. Okay, so the chi-square to the left, the chi-square to the left, L for the left is 0.989, and the chi-square to the right, which is the bigger number, is going to be 20.278. Okay, any question? No, we are almost done. We get the formula and we find it. Okay, the one that we have. Any questions? So be careful. It's the 99%. You get the leftover 1% divided by 2, 0.5% to the right, 0.5% to the left. The chi-square will read the area to the right only. So here is going to be 0.005, and it's going to be 99.5%, which is 0.995. Now we can get the formula and then be done. And we go for the variance first. Okay, that's the interval. This is the formula, okay? And the formula sigma squared is less than n minus 1. That's s squared. This is the chi squared. This is right, but we have to use the left. Okay, and this is going to be n minus 1 times s squared. The chi squared. Again, this is left. We go to the right. Okay, now we substitute. N was 8, so that give it 8 minus 1 s squared, which is 4.5 squared. Okay, divided by the chi squared to the right. The chi squared to the right, the bigger number, is 20.278. Okay, and this is going to be less than sigma squared, less than, and that's 8.8 minus 1, 4.4 all squared, and the chi squared to the left, which is simply 0.989. Can we simplify it to get this result? Okay, you can check it, but I have 0.8 less than the sigma squared, and this is less than 140. Okay, so that's going to be for the variance, but we are interested in standard deviation. Take the square root, so that give a 0.8 sigma and 140. And if you do it, so that give a 0.89 less than sigma and less than 11.8. So this would be the total in question. Okay, it's going to be in percent. So it's going to be between something like, 11.8% or 0.89% that they give you. Just, make a comment that, for example, there is, in this case, there is a 99% chance, 99% chance that the population, that the population standard deviation of those home ownership standard. Okay, the population standard deviation is going to be between, okay, that's going to be between, it's going to be between 0.89 and 11.8. And you're done. Okay, so these are the only possibilities for the, when we talk about the, okay, talking about the confidence interval for the variance or standard deviation. Either one of them, either one, with a sample. You have to do this type of ideas with a small domain to find the standard deviation yourself. You may have to do it for the case of the standard deviation, or you may have to do it for a kind of t-distribution case. Okay, any question? Now we are done with the confidence interval. So we did all sorts of confidence interval for the Okay, we did it for the mean, 2 cases, a confidence interval for the proportion, confidence interval for the standard deviation. We already done with the mean in your previous test. So on the quiz, you are going to see the confidence interval for proportion and the confidence interval for standard deviation. So far, okay, and we have more to go. So what we're going to do, we're going to go to the chapter 8. What's going to be the next step? So what we did so far, you see what we did so far, we collect a sample, for example, and we check the sample mean, sample proportion, or sample standard deviation. And then based on that sample, we make a prediction. You see, that's a prediction. You have one sample and you predict this one for everybody. So the next step is going to be, you see, you are going to propose this one, this information. Somebody may challenge you. Okay, somebody will challenge you when you say that the mean is equal to 50. For example, with the situation you're going to have, somebody will come and say, oh no, it's not. When they say it's not, it's going to be a challenge. So when somebody say it's not 50, so the question is what it is. So you have to consider alternative. The alternative is going to be, it may be less than 50, or it may be greater than 50. So what we are going to do in this new chapter is we are going to test that claim. You see, you are going to test that claim. The claim is going to be called a hypothesis. So this procedure is going to be hypothesis testing. So we're going to test whether that claim is true or false. Okay, so at the end, you may reject the claim. Okay, you may reject the claim, or you may support the claim if you like. So this is going to be your job. The procedure is going to be like the case with the confidence interval that we did organize for you. Remember, I just start with the common sense. I built up something for case one, then we continue taking all of them together. We are going to do the same thing. We are going to do a claim would be given to us in terms of the mean so far, in terms of the mean, and then we are going to check it. So you got to be patient. I don't want to give you the formula right away. We are going to go through it, design a method. And when you design the method at the end of the day, it's very easy. Just a couple of numbers you substitute, get the result right away. Okay, but the designing and the expression that we're going to use are going to be very important. And you have to explain your method on the test, okay? And don't just give us a couple of numbers. And we hope to there are a couple of cases. There are 2 cases for the mean, and 1 case is for the proportion, and 1 case for the standard deviation. We try, the mean is more important than the others. So we get the idea with the mean, then we decide what we are going to do with the other one. So what I do is I do the mean, but we are officially done. But I would like to give you another concept. We call it a very short one, and we call it correlation and regression. So I may drop one of these tests and I go to the other one. But let's see how far we can go. Okay. So it's going to be a new concept. I think your book is chapter 8. So we are done with chapter 7. I update all the all the assignments. I just postponed the deadline, all of them to the end of the course, okay, which is May 25th. So I did, I think, everything on chapter 7, a couple of them in chapter 6, and the chapter 8. I couldn't get back to the other ones, I have to go and check it again, but you have the deadline all set up through to the end of the end of the course. So nothing to worry about the late admission. Okay, so let's do it. Let's design the problem. Okay, design takes times. I think it's 8.1. Let's say 8.1 and 2 maybe. Let's see. I'll go with 8.1 first. So what is this one? It's going to be the procedure is called. There's lots of expressions. to be able to do something. So be patient and learn these expressions that you have to use. So this procedure is going to be called hypothesis testing. And sometimes they call it test of the significance. I'm going to explain that one when we get to it. Okay, so what's the procedure? The procedure is going to be, we are going to be given a claim. So that give you these definitions. Be patient, we get to that one. Okay, now in our job, in statistic, you let me know, if you have any doubt about this definition as we go on. So in a statistic, a hypothesis, okay, it's a hypothesis is going to be, so the hypothesis is a claim. Okay, is a claim, this expression that you see quite a lot, or a statement. Claim or a statement. Claim or a statement about a property. Okay, about a property of the population. Or the property of a population. Property of the population. Those property are going to be such, the one that you know it. Such as mean. Okay, it may be regarding the mean. Okay, maybe proportion. Proportion. Okay, proportion or standard deviation. Or a standard deviation. So regarding one of them. Okay, so we want to test one of, so it's going to be test hypothesis for the mean, proportion, standard deviation, one by one. Now the expression hypothesis test is the procedure. Okay, a hypothesis test, or the other name is, or test of, okay, they call it test of significance. So the same expressions. Test of significance is going to be a standard procedure for testing. Okay, is a standard procedure. Standard procedure for testing a claim. Okay, testing claim about a property of the, as we talk about, of a proportion. Testing a claim about a property of the population. A property of a population. So these are the expressions that we have. Okay, so for example, somebody will claim the following, that we have to test it, for example. For example, a reporter, TV reporter, or etc. This is going to be a code. Okay, a reporter claims that the majority, okay, the majority of American drivers, American drivers ran red lights. Okay, it may be true or false, but it's going to be a claim that, if it's given to you, you have to test it to test it, you have to, you have to collect some information. You may go outside, okay, and check the number of the cars that running red lights, and then put the information together to be able, to be able to do it. Okay, so that's the name of the test and the procedure that we are going to go through it. Now, how are we going to do it? In order to do it, we are going to set up the following. Okay, so this is going to be the procedure, or we're going to do it for the mean, and then we can copy it for anything else you like. So this is going to be, okay, it's going to be hypothesis testing for a population, mean. So there is going to be a claim about the mean. When you read the problem, you realize they talk about a mean. So then you want to take care of it. So these are the expression that we are going to use. The first expression is called null hypothesis. Null hypothesis. It's the first expression that we're going to use. You see, null hypothesis is a claim that you are going to test it. We call it null hypothesis, and we have a special notation for it. That notation is going to be H0. H0 or H0. Okay, so a claim that's going to be tested, or hypothesis, to be tested, is going to be called, okay, it's called the null hypothesis. The null hypothesis, and is denoted, a special notation for it is denoted by, it's going to be denoted by H0 or H0, we call it H0. Okay, so the H0 is null hypothesis. So we write it down, H0 that, the mu is equal to the 50, the mu is bigger than 50, less than 50. That's a null hypothesis. Any question? So that's the claim. When you want to test it, you have to test the alternatives. Okay, so alternative hypothesis or alternative. So what is going to be alternative? What's going to be the other choice? Okay, alternative one. The alternative hypothesis is going to be denoted by H1. Okay, it's going to be H1, and it's going to be considered to be alternative. Okay, so it is going to be a case, a hypothesis to be considered otherwise, to be considered as an alternative to the null hypothesis, to the null hypothesis. It's denoted by H1. It is denoted by H1. Okay, so the H0 is going to be the null hypothesis, and the H1 is going to be the one otherwise, the one that we consider to be an alternative result. Okay, so what we are going to do is, you see, there are different ways to set up these problems. The way we are going to do it, we are going to make it so easy. So we are going to talk about the population mean for the time being. You see, this population, this claim that would give into about the mean would be around a specific given number. So they may talk about, mu to equal to the 50, less than 50, greater than 50. So what we are going to do is we are going to set up the mu h0 to be just that, the fact that the mu is equal to the specific number. Then we set up that alternative that we have. Let me just write it down to see what I'm talking about. There are different ways to do it, but this is much easier. We try to write h0 as an equality, not inequality all the time. Okay, so what we're going to do, we are going to considering in this case, or the first case that we have, we consider, okay, we consider the null hypothesis, null hypothesis for a claim, okay, for a test concerning, okay, a test concerning a population mean, mu, okay, always specifies a single value, that number that I talk about, a single value for the mean. Okay, so this is what we're going to do. We're going to write it down. So in this case, I just emphasize again. So we always, that's the easiest way to do it. And we always, it is a little bit different from your book, but that's the best method. So we always express the null hypothesis, we fix it. A null, okay, the null hypothesis for mu as following, as this is it, fix this one, h0 is the statement that the mu is equal to whatever is given to you. We call it mu0. Mu0 is going to be the given number, okay? So where mu0 or mu0 is a given number. Whatever is given, whatever number is related to the mean, we are going to call it equal to. So that's the best procedure for the h0, and we are going to do it, we see it in a minute, okay? Any questions? So this is going to be your statement for the h0 all the time. So a number would be related to the mu that we are going to test it, you call it mu0. And then we copy this one for, when we get to the proportion or we get a standard deviation all the time. So if this is going to be the h0, so what's going to be the alternatives? Okay, so in this case, what is going to be the alternatives? Okay, let's see if you can guess. If I give you mu equal to the 50 as a h0, what is going to be the alternatives for this statement? Any suggestion? We're testing for the mean, remember, for the mu. So you fix that the mu is equal to the 50, okay, 50 whatever. So if your statement is going to be mu equal to the 50, so what's going to be otherwise? Any suggestion for this statement? Any suggestion? If we say that your mean salary is, okay, mean salary is $10,000. So what would be the alternative for this statement about your salary? Any suggestion? You want to try?
Is it 0?
No, why 0? See, if I,
Because the alternative to getting like a salary is none.
no, I repeat the question again, you see. If I say that, your salary or my salary is, okay, is $10,000. So this is a claim, okay? So my claim is that the salary is $10,000. So what's going to be the alternative of this statement? It's not 0, because you have to connect your statement to the 10,000 that I talk about it. Any suggestion? Yeah. A salary, yes, that's it. Yes, Bill. A salary would be more than 10,000, 1,000, or less than. Yes, you're right. Yes. Yes, when we say $1,000 or $10,000, the alternative is going to be the salary is maybe less than 10,000. The salary may be greater than 10,000, and there is a third one. The third one is that the salary is not equal to the 10,000. So there are going to be 3 alternatives, and this is your job. You're going to have 3 different problems, and you have to look for these expressions that I talk about it. Less than, greater than, and not. Okay, so that's why we set up this. That's why I'm talking about it. I said that whatever is given, we just set it up equal to first. Okay, then we check what is going to be the possibilities, and they give you the hint for the possibility when they collect. Okay, so in this case means if you set up this one as is, so the possibilities in this case there are going to be what? There are 3 choices, 3 possibility. Okay, there are going to be 3 choices for the H1, for the alternative. Okay, alternative hypothesis. And this is going to be your 3 problems that you're going to solve for us. So you must look for these type of expressions. Okay, the first one, the expression would be given to as is, as this. The population, okay, the population mean is less than that specific number that you put here, less than mu0. So if you see this one, then we are going to write, H1. H1 is the fact that mu is less than mu0. You see, this is how you set up your problem. H1 is the fact that the mu is less than mu0. But as we did it for the confidence interval, remember, we did for the confidence interval, then we relate this one to the probability. Then we check to see where the probability of mu is going to be less than mu0. And then again, we did the other one. Remember, we changed it to the z, and eventually that would relate us to the finding the area, remember, to the left of the z numbers, because it's less than. That's why we refer to this case for our, okay, when we get to the probability, we refer to it as a left tail test. So in this case, we say that the test, so the expression that would be helpful when we want to make a decision, okay, is going to be called, so this is called a left tail test. Left tail test means if you want to find the z numbers at the end, you have to consider the area to the left. Okay, that's case 1. Any question? Second alternative, same thing but greater than. So the population mean, okay, the population mean is greater than, is going to be greater than mu0. Okay, greater than mu0, that's it. So in this case, we write we set up the H1 is the fact that the mu is greater than mu0. Again, it would end up to the finding the area to the right, and the test is going to be called, okay, and the test is called, okay, a right tail test, a right-tailed test. Okay, right tail test because it's greater than. Left tail test because it's less than. Okay, any question? There is a third case. That would be 3 problems that we're going to see it in a minute. Okay, so what's going to be the last one? The last one, the expression would be the population. Population mean is different. Okay, is different. Is different. It's going to be different from mu0. Okay, different from mu0. So again, we write H1 is the fact that the mu is not equal to the mu0. That's it. Less than, greater than, not equal to. Okay, when it's a not, it may be the first one or the second one. So that's why we call it, and the test is called two-tailed. And the test is going to be called a two-tailed test. A two-tailed test. Okay, so this is how we set up the H0 and the H1, the alternative that we're going to check. Okay, any question? So we set up our test, but the question is going to be, we need a machine to conclude what type of machine are going to use for the probabilities. So what we're going to do is we are going to change it. We are going to connect it either to the z-score or the t-score that you did before, and then we come back to the probability and we'll be able to find it. So that machine that we're going to use, so that's it. That's the step. Okay, that's step 1 of this hypothesis. You are going to identify the H0 for us and the H1 right away. So this is your first job. Okay, so the next step is the machine. What type of machine are we going to use for the probability? Is it the Z or is it the T? So this part is going to be called, this machine is going to be called, we call it test statistic. Okay, so the next part of this procedure is the part that we call it test statistic, not the statistics. Okay, machine. What is test statistic? So the test statistics is going to be the machine. Okay, the test stat, the statistic is the machine, is a number, is a value. Is a value computed from the information from the sample that we have. Okay, from the sample data. Because you need a sample, you have a sample, and based on sample, you are going to make a decision. Sample data, and it's going to be used for making a decision. Okay, and it is going to be used in making the final decision, in making the decision about the null hypothesis. Are you going to accept it? Are you going to reject it? Making the decision about the null hypothesis, about the null hypothesis. Okay, there are two different cases, of course. Z-test or it's like the confidence interval. It depends on the given information. Okay, if the sigma is given to you, use the Z. If the sigma is unknown or the sample size is small, remember n is less than 30, you have to use the T. So you've got to be careful here to pick the correct one. So there are two cases. For the test stat or the test statistic. So case one, if a sigma is known, sigma is given to you or it's known, then you are going to use this formula. Okay, use the Z naught equal to X bar minus mu naught divided by the sigma over radical n. Okay, otherwise, if the sigma is unknown, if sigma is unknown. Okay, sigma is unknown, and you know that in this case, then n is less than 30. So then you are going to use the T distribution. It's going to be T0. T0, and this is going to be X bar minus mu naught divided by S over radical. S over radical. So the first part, as usual, we call it Z-test. And the second part, we are going to call it T-test. This is the only algebra that we're going to do for us, okay? Just finding these two numbers. Okay, so we got the tool, we evaluated it. So the next step is going to be the probability. So you have to find, when you have these cases, that the mu is less than mu naught, greater than mu naught. So what's the probability that the mu is going to be less than mu naught? Now, this part is different. We have two different methods, and there are two different methods in your book. And one of them is a classic one. The classic one is like the one that we did, we draw the curve and we check to see what's going to be the critical area or the critical values. The other one is, they call it the modern one, we call it the p-value method. That's very easy. It's going to be very easy, and we're going to use that one, okay? Only p-value method. So what is going to be, so you got the Z, you have to answer the probability question. So that probability question is going to be called p-value. So we use only p-value method, which is very easy, and you see in a minute that it's nothing new, we just did it before. P stands for the probability. So that would be probability value. That's a p-value. Now, it's like the one that we did before. So what's a p-value? We are going to, this is how we find it. P-values, okay, can be computed or can be found by using the following. I'll just describe it for you so you know that it's not going to be anything new, okay? P-values can be found by using the following procedure. The following procedure. Now, you see, it depends which case do you have. If you have left tail test, okay, that's why I just described them. If you have a left tail test, remember the left tail means you have mu less than Z mu naught. So we can use the same procedure that we did for the confidence interval. You change this one into the Z less than Z naught. So your p-value, you see your probability would be p-value. p-value, okay, just we call it p, is going to be the probability that, okay, probability that z is less than z naught. And you know that this is the area to the left, and you get it right away. You see, this is going to be the case. So this is going to be, for example, your z number. So we go to the table or calculator, you find this area. This area is p, the p-value, a number, a percent. Okay, any question? So you must know what type of test you have. Okay, and you already designed it. So quickly you can find it, this one or the calculator. So that's a case one. Case two, right tail test, right tail test. It's going to be the case that the mu is greater than mu naught. It would be end up with the z to be greater than z naught, the area to the right. Okay. So what is this? P-value is equal to probability that z is greater than z naught. You know, what does it mean? This is going to be your curve. This is your z naught. So we are interested in this. Make sure you get the complement, okay, of that number. So this is going to be your p number. Okay, this is going to be p. You know that if you want to read it from the table, you find the z number, its area to the right, you have to find the complement to get the result. Okay, so that's going to be the second part. Any question? The third part is not equal to. Okay, so you're done. So the third part, when it was different, two-tail test. So the two-tailed one. Two-tailed test. The two-tailed one is going to be when the mu is not equal to the mu naught. Okay, so this basically means if you change it to the probability question, it's going to be p-value equal to p of z not equal to the z naught. You see, for not equal to the z naught, what you can do is you can find the probability that z is less than z naught multiplied by 2, because it's going to be, this is what we are going to have for this case, you see. Not equal to, you have to, this is the z naught. And then the alternative here is going to be negative z naught. So you have to find this area and this area. So this would be half of the p-value, and this is going to be another half of the p-value. So you have two choices. You may find this one multiplied by 2, or you may find this one multiplied by 2, depends on the problem. This one is easier, because for the area to the left, you don't have to find the complement. Whatever you find, you multiply by 2, or you can do the other one. Okay, so my suggestion is this is going to be twice of the p of the z less than negative z naught, which is the same as twice of the p z greater than z naught. Okay, so we find one of them and we multiply by.
Professor, I have a quick question for
Yes.
you. So, like, when we did the confidence level with 99%, and it was like we found out that, okay, like, we
No,
have
no,
one left
there
over.
is that.
Is P supposed to
No,
be
no, no.
1, like in this case?
For the area, yes, it's going to be the same thing. You see, when you want to find the z
And
number.
then, yeah, because you said to write it as like a percentage, so I got confused what you meant by that.
No, all of them are percentage, can be percentage because they are all probability.
I see.
You see, when you find it, all of them are probability. They are going to be all less than 1. So you write it down in percent.
I see.
Okay, because you know that these are related to the Z and SAR area.
Yeah.
Okay, so this is going to be, so we got the probability. Okay, one more step to go. I want to give you all the steps and give you a break and we come back to do it. So we find the probability of if this is going to be happened. Okay, now when you find the probability, you have to make a decision. Okay, at the end. Remember, there was a claim. There was a claim that you have to tell us regarding these numbers that you have. So how are you going to decide about the claim? Are you going to accept it or are you going to reject it? Remember at the beginning of the course, we argue about that. We set up a level of for the probability. The level was 5%. So if the probability of everything or that event was less than 5%, we consider it to be 0. So this means that that happened, that event is not going to be happen. So for this type of problems, that level of the 5% that we just pick it ourselves before, it would be given to you. Then you have to compare this number with that level. Okay, this level is going to be called significance level. You see, in the case of a confidence interval, you did have confidence level 9%, 95%. Over here, they give you the bond, they give you the restriction, okay, that you're going to have. So you have to follow the instruction, not the 5% that we did before. So this is going to be called, that would help us to get the concluded result. We call it what is we call significance, okay? Significance level. What is significant limits? It's going to be used for making the decision. It is, it's the case that we do with the p-value. It's the probability. Is the, okay, it's going to be a probability of rejecting or supporting. Rejecting. Or can we say that rejecting the null hypothesis? A null hypothesis when it's true. You will understand when we get to the actual example. It's denoted by, we have a special notation for it, alpha. It is denoted by alpha. Alpha, and it's going to be used to make a decision. And it is used, it's going to be used to make a decision. To make a final decision, a decision regarding rejecting or supporting, supporting the claim that we are going to, we're trying to check it. So this would be given to you. You're not going to get it yourself. It's always, 1%, 5%, or sometimes 10%, but it will be given. Depends on the situation they're going to have. Okay, so you do all this job, you compare it with the alpha, and this is how we're going to conclude the conclusion. Remember, at the end, you have the p-value, probability, and alpha. So this is how we conclude. If your p-value is going to be less than the alpha that you have, okay, less than equal to alpha. Alpha is 1%, your probability is even less than 1%. If this is going to be the case, you reject the H naught. Reject the H naught. See, when you reject the H naught, this means you like the H1. Then you make a comment. Okay, depends on the given problem. And if P is greater than alpha, in this case, you do not reject the edge node. You support it, okay? Do not reject. Do not reject the edge node or support. Okay, support the edge node. We don't say accept. We just support, reject or refute. This is, different expression that we are going to have. That's it. You find the P, you compare it, and you make a comment. Of course, you have to make a comment regarding the claim. And some people, they miss that last column, last claim, if you like. Okay, that's the all procedure that we're going to have. Give you a break. We come back and we do it. This is an easy procedure, and you will get it right away. And it's quite interesting one. You must make sure that you use the proper statistic. I mean, if the sigma is given to you, are going to use the z-test as usual. If the sigma is missing or the sample size is small, you have to use the t. I didn't talk about the t, p-value for the t. I'm going to talk about that later. Okay, it's 10, 11, 26, 10 minutes. We come back and we do it. Three problems on the squeeze from this one. And we give you 3 examples to finish the mean. Okay, that the practice one that I posted for you is just up to this point. There is nothing else, but we have to practice to get to that. Okay, see you in 10 minutes. Okay, so what we're going to do, we are going to try to give some examples. So we are going to set up this information. I'll go with a couple of cases that we just give you a brief one when the information is already collected. Okay, then show you how we're going to do it when we get a real example. Okay, so to now set up the test first. Okay, so give you the first example. So we need the three cases. Okay, the first one. First one is, suppose you want to check this claim. So you have to identify the claim, and this problem, the claim is given to you. So the claim is that the fact that the mu is less than 5.3, that's a claim that we want to test. So you need information, and this is all the information given. What is going to be sample data. Okay, the sample data would be start with the sample size. So the sample size is 32, n is equal to the 32, and the sample mean x bar is equal to the 4.2, and the standard deviation is given, sigma is equal to the 1.9. 1.9, and we want to test it against the alpha equal to the 1%. Alpha would be given to you 1%, which is going to be 0.001. So this is all the information that you have to collect from the given problem. So this is going to be the procedure. You have to set up the test first. Okay, so this is the solution, and this is the way you're going to write the solution for us during the test. So we start with the H naught. Okay, the H naught, we talk about it, is always as an equation that will cover the given quantity, the number. So it's going to be the fact that the mu is equal to the 5.3. That's going to be the H naught. H1 is the alternative. Alternative is given to you, the one that you want to check. Okay, so we want to check if mu is less than 5.3. Remember, we talk about it, when you see the expression less than, so you write mu less than 5.3. You identify the type of the test that you have is less. When it's a less, is a left tail test. Okay, so left tailed test. That is going to be a step one of the solution. Any question? So as we talk about, the mu naught is always the equation. Mu is equal to that number, 5.3. H1 is, the claim is that the mu is less than 5.3. So mu less than 5.3. It is going to be a left tail test. Okay, that's step one. Step two, the machine, test a stat. So what is going to be test? A statistic. Test statistics, you have to decide which one is it. Is it the Z or the T? Sigma is given to you, so it's a Z. Okay, so you are going to mention it that the sigma equal to the 1.9. Okay, is given, and so, okay, and so the Z test. I just explain it for your information. The Z test should be applied. Should be applied. So it should be applied means you go with the formula, you see Z naught or Z. Z naught is going to be equal to the X bar minus mu naught, okay, divided by the sigma over radical n. Sigma over radical n, now you substitute. X bar is 4.2 minus mu naught is 5.3. 5.3 over the sigma is 1.9. divided by the square root of n. N is 32. See, this is how you set up the formula. Okay, you can use your calculator to get this number. And if you want to subtract it, it's not difficult. The top is going to be a negative number. So it's a negative 1.1. And use the calculator, I have a 0.34. So that gives you divide two decimal places. It's going to be negative 3, 2.3. So the Z naught, okay, the Z naught would be negative 3, 2.3. So that is going to be the second step. Finding the Z or finding the T. Any question? So that's important not to miss have to use the proper test. Next, p-value probability. Okay, what is going to be p-value? So you know that you have a left tail test. So it's area to the left. Okay, so remind yourself that you have a left tail test. It is a left tail test. Left tailed test. These are for your information. You can write it down. Give us the result right away. We accept it. Okay, so for the left tail, so the p probability is going to be probability that the z is less than z naught. Less than z naught, and in this case, going to be z less than z naught, which is a negative 3.23. Okay, you can use calculator or you can use the table. Okay, this is it. This is what you have, a negative 3.23. So this is the area in question. Okay, you can use your calculator if you like, or simply the table. Okay, the Z table for the negative 3.23. Just wanted to see it. This negative, that is a negative 3.23. Okay, negative 3.2 and 3, 0, 1, 2, 3. Okay, it's a 0.006. 0.0006. Okay, so this is point, okay, 0.006. So that would be your p-value. So your p-value is very small. Your p-value is a 0.006. It's like 0.6%. Okay, that's a p-value. Any question? So that is step 3, the p-value. The last step is conclusion. You compare it with the alpha and you tell us what are we going to do. So the conclusion. The conclusion is that the p is equal to the 0.006. Alpha is 1%, which is 0.01. You compare them together, as you can see, p is less than alpha. Okay, so the conclusion is that the p is less than alpha, and then you reject the H naught. Okay, so you reject. Okay, that's it. Reject the H naught. If it's bigger than alpha, you do not reject the H naught. Okay, but you are not done. You have to tell us what you're going to do about the claim. You see, when you reject the H naught, this means you support the alternative. Alternative is H1. So you have to write something nice about the H1. You see, something nice about the H1 means this is the way we write it down. You believe in H1. That is something nice. But the way we write it down is, this is how we word it. There is sufficient, okay, sufficient evidence, the one that we did. Sufficient evidence that mu is less than 5.3. So we are going to support the claim. Support the claim. We don't usually say except. Okay, support the claim based on this information. Yes, you know, what else can you do? Based on this information, you are going to support the claim. Okay, so the conclusion is important and it's going to be graded that if you just say reject the H node, you're not done. You have to connect it to the, okay, connect it to the claim. What would happen to the claim? Again, when you reject the H node, means you are in favor of the H1, which is the alternative. And in this case, the alternative is the one that you are looking for, and then we're done. Okay, any question? So that's how these problems are going to be explained. So this is going to be one case, less than. Let's have another one with a bigger than, then I give you the actual one. There's going to be a story, and then you put these numbers together and you make a decision or the claim. So let's have another one, another claim that we want to test, and you give me one from each, and you already posted on that practice quiz that I posted. Then we go over it on Thursday. Okay, so what is going to be this? There is a claim. It's a claim that, about the salary or something. So the mean is bigger than 24,819. It's the one that we're going to check. So we need to test it by a sample. So we have sample information. So sample data. The sample data start with the sample size. In this problem is 40. The X bar is 25,910. And it's going to be the sigma. Sigma is 1,917. And you want to check it against alpha equal to the 1% again. So alpha would be given to you most of the time is a 1%, 2%. Okay, as you can see in this case it's greater than. So we set up the problem. Are you ready? Any question? Set up the problem. The H node is, as we talked about it before, always we go with the equality. So mu is equal to the quantity that's given to you. It's 24,819. Okay, so the alternative H1 is greater than. So mu is greater than 24,819. Since it's a greater than, it's a right tail test. Right. Okay, tailed test. Okay, it's going to be right tail test. That is step 1. Okay, step 2, you have to identify the test stat. Again, the sample size is very large, bigger than 30, and the sigma is given to you. So we can use the z-test. Okay, so the next step is going to be what is the test statistic. Test statistic. Then you emphasize that the sigma equal to the 1,917 is given. And the z-test can be applied. Z-test should be applied. Okay, z-test should be applied means that's it. Z naught is equal to the x bar minus mu over sigma over radical n. So it's going to be equal to the x bar. X bar is 25,910 minus mu of 24,819 over the sigma 1,917 over the radical n, which is 40. Okay, you subtract it, and the top give you 1091, and I have 303 for this one, and if you divide it, that gives you 3.6. So the Z naught is equal to the 3.6 for this case. Okay, just make sure you could use the proper formula. Any question? Go and find the probability, p-value. It's a right tail test, so you have to make sure paying get the complement. Okay, so the next step is going to be what's the p-value. Okay, the test is the right tail test. Okay, so remind yourself that it is a right tail test, right tailed test. So for the right one, the probability is just a p of z to be greater than z naught. In this case, it's going to be p z greater than 3.6. It's the area to the right. You can use your calculator, or if you want to use a table, it's a 3.6 and the area to the right. So you have to find the complement. So it's going to be 1 minus 3.6. You don't have it on the test. On the table, you just pick the last possible value, because the most that you have is a 3.4. You know, they asked to just call it 1, but we don't usually go with the 1. We go with the last number here. Okay, even if you go with the 1, would be fine. But the last number is going to be 0.9998. Okay, so it's going to be 0.9998. Okay, so the leftover is going to be always 0.002. Okay, so this is going to be 0.0002. It's very small. So your p-value again is a small 0.0002. That's it. Any question? So for this case, make sure you get the complement if you don't use your calculator. Again, you can use your calculator for the, since you use the Z number, you know that you have to put the mu equal to the 0 and the sigma equal to 1 to get this number. Okay, conclusion is that the p is very small, 0.0002. Your alpha is 1%. Okay, 1%, which is going to be 0.01. So if you compare them together, again, p is less than alpha. So we're going to reject the H naught. Again, rejecting the H naught means you are in favor of the H1. So H1 is the claim. So you support the claim. Okay, so you can write something nice. Or if you just say support the claim, we accept it. So the expression that, that's used in your book all the time is there is sufficient evidence. Okay, sufficient evidence to conclude that, okay, to conclude that otherwise is going to be correct. Okay, to conclude that the mu is greater than, because you go with the alternative 24,890. So you support the claim. Support the claim. Okay, so this is how you put this information together, okay, to get the actual one. So this tell you that how we're going to collect the information when it is given to you. Okay, so what we're going to do now, we give you an example, a real one, to see how the example would be given and how we're going to set up the test for the actual one. Okay, any question? So again, pay attention the way we are going to do it, and we shouldn't have any difficulty. Okay, now let's see what's going to be the real one, and because we need a third case. So I give you the third case with with this information. So the example is going to be regarding the body temperature. There is a fixed number for the body temperature, but which is a 98.6. For some people, they believe it's not true. So there is going to be a sample they want to test it. There's a claim that we tested. Okay. So let's get that one. So you should be able to do most of the problem on that practice one that we posted for you. But we need more examples. We need example for the T. Let's try this one first. Okay, are you ready? Actual example. Situation would be given. We want to know how you identify that this is a test hypothesis problem. Okay, so what's the example? Information regarding the body temperature. A data. Okay, a data set lists. Okay, list a sample. A sample of 106 body temperatures. Okay, body temperature. Body temperatures. Okay, having a mean. A mean of. Okay, mean of 98.20 degrees Fahrenheit. Okay, so we measure the body temperature of 106 persons, and the mean happened to be 98.20. So what's the question? Suppose we know the population, okay, standard deviation for everybody. Suppose the population, standard deviation, standard deviation. Standard deviation is known. Okay, is known to be 0.62 degrees Fahrenheit. Okay, so the standard deviation is also given to, sigma is given to. So what's the question? The question is, they ask you use a 5% significant levels. You see, as soon as they talk about the significance level, you realize that this is the problem of the test hypothesis. Okay, so use the 5% significance level. Okay, level to test. Okay, to test what? To test the common belief that everybody believe it. The common test that the common belief. Common belief that the mean body temperature. That the mean okay, that the mean body temperature using another one. Okay, we did that the mean body temperature of healthy adult. Okay, the adults is equal to 98.6. 65. It's a very tricky example that claim or handling. It's interesting, you know, not that difficult, but we got to be careful. Okay. So as you can see, we read the problem. You go right to the end of the problem to see what is going to be the claim for these problems. So we realize that 5% significant limits is given to, and they want to check the expression that the mean is equal to the 98.6 degree Fahrenheit. So that would be the claim. Okay, so because you have to identify the claim, and the claim is right through the end of the problem. So the claim that we're going to check is, you see, that's going to be your claim. You have to identify it yourself. So the claim is that the mu is equal to the 98.6, okay, Fahrenheit degrees. That's it. That's a claim. So you need the sample information. Okay, so what is your sample data? Sample data. The sample data start with the sample size. We have 106. Sample mean for those 106. The mean is 98.20 or just 2. Okay, so this is going to be, that is the degrees. And what else? We have the standard deviation of the population. And the standard deviation is 0.62. You want to check this one against the alpha equal to the 5% this time. Okay, so the claim is that the mu is equal to the 98.6. We want to check this claim. And this is the information that we have. Above 160 people, the temperature is 98.2, a standard deviation of 0.62. We want to check it against the alpha equal to the 5%. Okay, now you have to set up the test. Okay, so to set up the test, the H node is clear. You see the H node, we always write down as equation, and this is also an equation. Let's make it interesting. So the H node is the fact that the mu is equal to the 98.6. Then H1. Any suggestion? What's going to be H1 in this case? What is the alternative? Any suggestion? Because the given one is equal to, the alternative is going to be
W is less than?
no.
No?
No, because you see, look at the given one. So the claim is that the mu is equal to the 98.6. So you have to make an alternative for this one, is. Because this is equal to, okay? It's equal to. The alternative for equal to means not equal to. You see, because it can be less than or it can be greater than. So when the claim is the fact that is equal to, okay, so your alternative is going to be mu is not equal to 98.6. Okay, so be careful regarding this one. Any question? So all the other one, the other case that we have, let me maybe give you one. You see, this may be in the description that we talk about it. We considered the case that the mu is not equal to. You see, that was when they describe it. But the equality sign is already the claim. So since it's already the claim, and we usually write the H naught as equal to, so for this one, you have to set up the H1 to be equal to the fact that the mu is not equal to. Okay, so let's make it different. Okay, any question? Now we have a two-take test because it's not equal to, okay? So it's a two-tailed test. Even when you want to write the conclusion, this is interesting. Okay, so that's going to be a two-tailed test. So we go to the test stat, test statistic. Okay, statistic. Again, the sigma is given to you and the size is very much bigger than 30. Okay, so you claim that the sigma equal to the 0.62 is given. And so the z-test. Okay, the z-test. Okay, or the z-test test should be applied. Or just write the formula, we accept that. Just explain it for you. So the z naught is going to be, as we expected, it's going to be x bar minus mu naught. Okay, over the sigma over radical n. Okay, that's it. That's going to be the case. Now we substitute. It's going to be equal to, okay, getting the x bar of 98.2. 98.2 minus mu naught. Mu naught is a 98.6. Divided by the sigma 0.62, and the square root of 106. Okay, so this is what you have. You can use your calculator. The number is negative and it's a very large number. Compare it with the value for the z, is a negative 6.64. That's the number. I think it's correct. Check it with the calculator. On the top is you get the negative 0.4. You get a negative 0.4 to get these numbers, and just check it. I know it's before, it shouldn't have any. The number. So on the top, when you subtract it, that give you negative 0.4. Then I want to divide it by, and that's a 0.62 divided by the square root of 106. Yes, it's correct. It's a negative. Okay, it's a negative 6.64. Okay, so that's going to be the z naught, which is going to be negative 6.64. Okay, so this is going to be the test statistic. Any question? You have to find the p-value, which is interesting. For this case, it's a two-tailed test. So I'm going to go to the next page to get the p-value. Okay, so what is going to be the p-value? The probability, and remember we have a two-tailed test. So it's a two-tailed test. Two-tailed test. So this means that the p is going to be probability that z is not equal to the negative 6.64. Remember, we talk about it's going to be twice of one of these. You see, that's going to be the one. So you have the positive 6.64 here, and this is a negative 6.64. We talk about it, we can get one of them and multiply by 2. You better get this one, because you don't have to go with the complement. So the p is going to be twice of the p of the area to the left of the negative 6.64. This number is not in the table, okay? So if you check with the negative numbers that you have on the table, You see, this is the most that you have for the negative numbers, negative 3.4, and we pick the last number, which is 0.0002. It's almost zero, but we don't usually go for the zero, okay? So it's a negative 3.4, and it's going to be 0.0002, and you can use your calculator too. So it's going to be 0.0, oh, I'm sorry, it's going to be 2 times, okay? So this is going to be 0.0002, but you have to multiply by 2 to get the p-value because it's a 2 different region. So the p is going to be 2 times 0.002, which is going to be 0.0004. Again, is very a small number for the p-value. Okay, any question? So be careful about finding the p-value. Now the conclusion. What's going to be the conclusion? You compare it. So this is what you have. Your alpha is 0.0004. Sorry, your P. Your alpha is 5%. 5%, which is going to be 0.05. You compare them together, the P again is less than alpha. And you're going to reject the H naught. Reject the H naught. Okay, so you just go back to see what's going to be the conclusion. When you're rejecting the H naught means you believe in H1. Okay, you support the H1. And what is the H1? You see, reject the H naught, you're rejecting the fact that the mu is equal to. So there are sufficient evidence that the mu is not, okay, mu is not equal to the 98.6, and then you reject the claim in this case, or refute the claim, because the claim was that this is equal to, not, you see, you reject the H naught here. Okay, so you can quickly, okay, that you don't support the claim, or as usual, something favorite for the H1. There is sufficient evidence, okay, to conclude otherwise. Conclude that otherwise means mu is not, okay, mu is not equal to the 98.6. Okay, but the claim was that is equal to, so you are going to do not support the claim or refute the claim. Okay, that's it. Do not support the claim. Or sometimes the other expression is refute. Refute the claim. Okay, so this last one is a little bit tricky. You got to be careful, and when you compare it to get your final conclusion. But otherwise, basically it's not a difficult job to do to get these numbers. Okay, that's it. We need an example for the t distribution. For the t distribution, to finding this, you can use a calculator that I'm going to show you next time, but with the table is very easy to find. So make sure you bring this part of the table with you next time. So to show you very nice method with the table. Remember the t distribution. You see this one? Previously, we just used this part only. We didn't use the second and the third. Look at the first. One tail area, two tail area. So that would be used when you want to use the test hypothesis regarding the t. It's a very, very easy method. The fact is that when you want to make a decision, you don't need the exact number of the p. You just want to compare it with the alpha. So this table would enable you to compare it with the alpha without knowing the exact value of the p. So that would be very easy. Otherwise, you can find the exact value of the p by the calculator and just compare them together. But we don't need it. But we discuss both of them for you. then you can decide what you want to do. Okay, so we need 2 more examples to be ready for the quiz. So we discuss this first, and then we go over the practice quiz that are posted for you. It's a very good one. 7 or 8 questions, and of course, we give you a similar one on the final. So have a look at it, and I finished these 2 next examples. I'm not going to give anything else for the test hypothesis. We have one for the proportion. It's very easy. So we may drop it. You can read it for yourself. We are not going to question you, because the main is the main one really. And to see what we can do for other, because we need 1 lecture to review, and we have an extra one. We may use that one to give you correlation and the regression, a short idea really, and then you get an idea of everything. But we are set on time, you know, the official content, we cover it already. Okay, that's it. So have a good one. I checked the recording. I have to wait for this one, but I post if there is anything missing. I post the other one too, and I continue grading your test. Okay, I studied this one quickly. It's another difficult one, but interesting. Let me know if you have any question. Have a good one. Take care. Bye-bye.